Welcome dear students, 8th class Math new book chapter number 3 Understanding Quadrilaterals. The first exercise 3.1 which has got two questions. So both these questions we will do in this video. Watch and listen to the video very carefully, note down all the answers, but later on make sure you practice doing all these questions on your own. So let's get started. Question number 1 is given here are some figures. So these 8 figures are given and they say classify each of them on the basis of the following. So we have to do the classification. First classification is simple curve. That means which of these figures come under the category of a simple curve. Second is simple closed curve. Which of these figures come under the category of simple closed curve. Polygon. Which of these are or is a polygon? Which one is convex polygon? Which one is a concave polygon? Now we can do this classification if and only if we know what is a simple curve, what is a simple closed curve, what is a polygon, what is a convex polygon, what is a concave polygon. So we must know these definitions. So dear students, for your guidance, I will do the classification and also tell you and explain you about the definitions of these terms. So listen very carefully and note down all these definitions in your notebook. First is simple curve. What in fact is a curve as per the mathematics, as per the definition given in mathematics? A line, a curve or doodle, whatever you can draw without lifting a pen or pencil in one go, without the help of any external instrument like a ruler or a compass or anything else, that is known as a curve. So what is simple curve? A curve that does not cross itself is called a simple curve. You see, nowhere in these figures the line is crossing itself. So a curve that does not cross itself is called a simple curve. Thus 1, 2, 5, 6 and 7 are simple curves. Next. Now what is simple closed curve? A curve that does not cross itself, that is for simple, and whose both ends meet is called a simple closed curve. You see here the ends are meeting. Ends are meeting. There is no loose or open end. Let me explain you what is the meaning of open end, and then it would have been known as simple open curve. Let's say this line is missing. This line is not there. You start from here, you draw, 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 draw and come to here. You do not go here. You stop here only. Then this end is loose, open. This end is also open. Then it would have been known as simple open curve, because in none of these figures there is any loose open end. So all these curves which were in the first category simple curves, they are also simple closed curves because the ends are meeting. Thus 1, 2, 5, 6 and 7 are simple closed curves. Next is polygon. What is the definition of a polygon? A simple closed curve made entirely of line segments is called a polygon. The other figures, they were not made of line segments. These are straight line segments. So this is actually a pentagon because one line segment 1, 2, 3, 4, 5. And this is a quadrilateral 1, 2, 3, 4. So thus 1 and 2 are polygons because both of these are not only simple closed curves, they are made of line segments. They are made of line segments. There are no arcs. Arcs are not there. If you see the previous slide, part A and part B, the 4 figures which came under the category of simple closed curves, the other 4 figures, they have arcs in them. They are not made entirely of line segments. Now D, categorization of polygons. Convex polygon, concave polygon. So what is a convex polygon? A polygon which has no portion of its diagonals in its exterior is known as a convex polygon. Another thing is a convex polygon has all its interior angles less than 180 degree. These are two definitions. These are not two conditions, because if a polygon meets this condition, second condition will automatically be met. So you can say, you can define convex polygon in one of these two ways. In convex polygon, all the diagonals, they lie entirely in its interior, and all the interior angles are less than 180 degree. Now you see, this is a quadrilateral, okay, and it has got two diagonals. This diagonal is totally inside the quadrilateral. This diagonal is entirely inside the quadrilateral. No portion of any diagonal is going outside the quadrilateral, outside the polygon. So that is why it is a convex polygon. And you see these angles, these four angles, each of these angles is very clearly, by just looking at it, they are less than 180 degree. Thus only number 2 figure is a convex polygon. Next. Now you will understand better when we talk about concave polygon as well. Concave polygon is just the opposite of convex polygon. A polygon which has at least one diagonal lying in its exterior is known as a concave polygon. And another way of saying this is, a concave polygon has at least one of its interior angles more than 180 degrees. So thus only one, figure number 1, is a concave polygon. You see now, one diagonal is this, which is in the interior. One diagonal is this, which is in the interior. But this diagonal is lying outside because polygon is from here to here. And this diagonal is lying outside the quadrilateral, outside the pentagon, outside the polygon. So that is why it is a concave polygon. And if you go by the angles, you see this angle is less than 180 degree. This less than 180 degree. This is less than 180 degree. This is less than 180 degree. But this angle is more than 180 degree. So when at least one angle is more than 180 degree, then that polygon would be known as a concave polygon. Or we can say, when one diagonal or any portion of any diagonal lies outside the polygon, then it is known as a concave polygon. Next question. Question number 2. What is a regular polygon? We have talked about polygon. We have talked about a polygon. We'll talk about a regular polygon. So what is a regular polygon? And three more parts are there in these. One is part A. Part 1 is, state the name of a regular polygon of 3 sides, 4 sides and 6 sides. So first we will define what is a regular polygon. We have already studied about a polygon. What is a polygon? Polygon is a simple closed curve made entirely of line segments. And what is a regular polygon? A regular polygon is a polygon which has equal sides and angles, in which all the sides are of equal length and all the interior angles are of equal measure. That is known as a regular polygon. In other words, a regular polygon is both equilateral. Equilateral means having equal sides, and equiangular. Equiangular means having equal angles. All regular polygons are convex polygons. You can add this and remember this additional information connected with the regular polygons. All regular polygons are convex polygons. You will never find a regular polygon which is a concave polygon. So now part 1, number 3 sides. We know that a polygon made of 3 sides is known as a triangle. But if all the 3 sides are equal, all the 3 angles are also equal, then it is known as an equilateral triangle. And we know about 4 sides. If a polygon has 4 sides, we call it a quadrilateral. But if all the 4 sides are equal, all the four angles are equal, then it is known as a square. And six sides, we call it a hexagon. But if it is a regular hexagon, if it has got all the sides equal and all the angles equal, then we simply call it a regular hexagon, regular pentagon, regular heptagon, regular nonagon, regular decagon, regular octagon, like that. Octagon means 8 sides, nonagon means 9 sides, decagon means 10 sides. So dear students, these were the only two questions of exercise 3.1 of this chapter on quadrilaterals. So keep doing your studies in a regular and disciplined manner like this, and goodbye till the next video. Thank you very much.